So one of the more difficult units that we had, right, was quadratics. All right, and so I wanted to talk about that and just review that a little bit with us here. We already talked about it somewhat today in the warm-up and stuff, but I wanted to talk about it again, okay? So let's zoom in here on the top, and we're going to use this quadratic right here. We're going to answer questions 1 through 10. That's the entire front here we're going to use to answer this. So number 1, okay, we're going to talk about the degree of the function. So let's go to Chloe. Chloe, what is the degree of this equation right here? What's its degree? Oh, okay, let's go to Jasmine. Jasmine, what is the degree? Don't know. Okay, moving on. Let's go to Anna. Anna, help us out. What's the degree? Oh, no. Save us. Alyssa. Don't know. Oh, no. Let's go to Jackson. What's the degree? It is not 6. Let's go to Ethan. Help us out, Ethan. What's the degree?
3x.
Oh, no. Keep going here. Braden, help us. Save us, Braden.
You caught me off guard.
No. Okay. Frank?
Quadratic.
What's the degree, though?
Oh, shoot. Yeah.
Number. 2 is the answer. 2 is the degree. You don't need a graphing calculator. How do we determine the degree? Okay, right. What is the degree? It's what? Highest exponent in the function. Okay, in the polynomial. Highest exponent, the greatest exponent in the polynomial. Degree. Okay, greatest exponent in the polynomial. Yes, sorry to those of you that were like frantically waving your hands in the air. I figured you guys had a good idea, but I just wanted to. Yes, you may. Okay. Yes, sir. Okay. All right. Whew. Let's try number 2. Let's go to Olivia. Olivia, is this parabola going to open up or down? Is it going to be a U or is it going to be a frown? Open up for the U, open down for the frown. Not sure? All right, Alyssa, help us out.
No, mine.
Oh, question.
Broken.
Your calculator's broken.
And like every graph that I put in hasn't worked.
All right, I'll come take a look at it. More importantly, though, let's go to someone else then. All right, thank you, Olivia. We'll get some answers here. Let's go to Eric. Eric, is this parabola going to open up or down? You're going to graph it? Okay, we'll come back to you here. I think we're going to be able to get an answer. Alessandra, help us out. Is it going to open up or down?
Down.
What makes you say down?
Negative.
What's negative?
-6.
True, but what's the lead coefficient here? 3. The A value is a
It's going to go up.
positive 3, so it opens up. Okay, A, which is equal to 3, is greater than 0. Okay, that's the key there. The A value, which is equal to 3, is greater than 0. Okay, opens up. All right. All right. So, is there going to be a minimum or is there going to be a maximum point? Let's go to Alex. What do you say, Alex? Is there going to be a minimum or a maximum point?
A minimum,
A minimum. What clues are there going to be a minimum?
because it's opening up.
Yes. Okay, it's going to, right, because we're opening up. Exactly right. Yep. Oh, sorry, John. Again, keep bumping you. Okay, so yeah, minimum point, okay. Our graph looks like this, right? And so that is a minimum point. What kind of A value will we need to have a maximum point? a negative a value, right? We would need a to be negative. We need our lead coefficient to be negative in order to have a maximum point. So this is a minimum point. What we got right there, minimum point. All right. Number 4, use the discriminant to identify how many solutions the quadratic has. Ooh, where do we look for the discriminant? Where is that? Anna? Or do you know what it is at least?
Yeah.
Oh, what is it?
It's negative 3 plus minus the square root of b squared minus 4 times a times c over 200.
Okay, that is the quadratic formula, right? Which, do we have to have it memorized? No, it'll be given to us on our formula sheet. But the discriminant, where is the discriminant in this formula? So, Olivia?
B squared.
Yes, this little piece right in here, that is the discriminant. Okay, so super good to remember the quadratic formula, but again, it'll be given to you. Pull out the b squared minus 4ac, that's your discriminant. What do the b, the a, and the c, what do they correspond to in our problem here? B is what in this problem? The negative 6, okay? Right. What is the c value here? 5, yeah. And what is the a value? Go ahead, Ethan.
3.
3, very good. Yeah, go ahead. And so we'll put in negative 6 for the b squared minus 4 times a, which is 3, times c, which is 5. Okay. And so negative 6 squared, we'll just type this into our calculator here. Okay. We get negative 24. Okay. What does this tell us? Yeah, what does that negative 24 tell us, okay, about the number of solutions, or the numbers of, well, not really solutions. It should be zeros. I'm not going to say solutions here. We'll say zeros. Okay. So how many zeros are we going to have here? We will have, no real zeros. Okay. Because this is less than 0. Okay. If the discriminant is greater than 0, if our discriminant is positive, how many real zeros do we have? If we have a positive discriminant, how many zeros do we have? 2. Okay, remember that looks like this. Okay, there are 2 real zeros. And if our discriminant is equal to 0, how many real zeros do we have? 1 real zero. Okay, and that looks like when you have a parabola that comes down and just kind of kisses the x-axis and goes right back up. Okay, just 1 0, just like that. Okay, no real zeros, what does that look like? That looks like when you have your parabola that never touches the x-axis. Okay, like that. You see it never touches. Okay, so that's the situation we have here. There are no real zeros. Okay, no real zeros because we have negative 24 as our discriminant there. Okay. All right. Okay. How about calculating the vertex? Ooh, okay, vertex. What's one way we could find the vertex of this quadratic here? What's one thing we could use to find the vertex? What is the vertex for a quadratic? What's the vertex? Go ahead, Scott.
It's like on the axis of symmetry.
Okay, it's on the axis of symmetry. That's right. Yep, it's either going to be our highest point or our lowest point, right? In this case, since it's this minimum point right here, right? Since we're concave up, it's this minimum point. We've got to find that point. And it is on the axis of symmetry. Scott, do you remember how to find the axis of symmetry? What we use?
Isn't it
Negative b over...
b over 2a?
Yes, and remember, folks, the axis of symmetry is that part in front of your quadratic formula right here, negative b over 2a. There is the axis of symmetry part. So your quadratic formula, of course, it's important because it helps us solve our quadratic equations, but it also has 2 important pieces in it. The discriminant, the part under the square root, and the part in front of the plus or minus, the negative b over 2a, that is also important. That's our axis of symmetry. So we'll go ahead and plug this in. Again, it's going to be negative, or b is negative 6. So negative 6 over 2 times a, which is 3. Okay. Negative 6 becomes positive 6 over 2 times 3, which is also 6. Let's see here. I got to like divide this up here. I'm going to run out of space. Which is just what? What's 6 divided by 6? 1. Now, there's the x coordinate. There's the x coordinate for my vertex. How can I find the matching y coordinate? What can we do with that x coordinate there? We've got our function, don't we? Plug it back into the function. Yeah, do f of 1. You have a question, Sky? Oh, sorry. Okay, yeah. You are right. Okay, so plug 1 in. Okay, 1 squared is 1 times 3 is going to be 3, minus 6 times 1, so minus 6, and then plus 5. So 3 minus 6 is negative 3, plus 5 will be 2. So we have the coordinate 1, comma 2. Okay, that's our vertex there. Sorry, I should zoom in or something. And I scratched out my answer. Okay. Question?
When I put it in my good calculator, it came up with -1. Like,
Did it? Let me see here. Did I miscalculate something?
I mean, I can always redo it. Oh, yeah, I did it.
Okay, I was going to say, I typed mine in correctly there. Yeah, so another way you could do this is just graph this thing, right? 3x squared minus 6x plus 5. Okay? So there's the vertex right there. You're just going to use, what command do we want to use here to find the vertex? What command do we want to use here to find the vertex? Minimum. Yeah, because it's the minimum of our graph. So make sure you're to the left of your vertex, hit enter, and then arrow over to the right of your vertex, hit enter, and then go down to the bottom and hit enter. And there's your minimum. 1, 2, right? That 0.999, we're just going to round that to 1 because it's just an error on our calculator. Part 1, 2, and there it is. Okay. What is the y-intercept? Okay, the y-intercept, what is that? How do we find the y-intercept? What do we know about the y-intercept? It's where the graph does what? Crosses the y-axis. So if we're on the y-axis, that means we have a x-coordinate of 0. And we just got to find the matching y-coordinate. So we can plug 0 in. Okay? So, bless you, plug 0 in for x. Okay? So just plug 0 in here. 3 times 0 is going to be 0. Minus 6 times 0 is 0. So it's 0, 0 plus 5. So it's just 5. You can also look on your graph here, okay, at the table, too. Second table. And there it is, 0, 5. There's your y-intercept, 0, 5. Okay, you can also do that on the table there. Okay, speaking of that, we're going to graph this. Well, we already have the y-intercept. It's at 0, 5. Okay, we also have the vertex at 1, 2. Okay? Because of symmetry, if we have a point at 0, 5, we'll also have a point at 2, 5 as well. Okay? And while it said identify a minimum of 3 points, well, we do have 3 points now if we use the symmetry there. So there's kind of like our graph. Okay, something like that. Okay? What is the domain of this quadratic function going to be? Negative infinity to infinity. What's the range of this function going to be? What's the lowest y value? I heard it. What's the lowest y value? 2. And we do get there. And then up to, what's the highest y value going to be? Infinity. Okay? The function increases on the interval. At what x value does it start to increase? 1. And then it increases as we go to the right, right? So 1 to what? Infinity. And again, we'll put parentheses for both of those. Okay? Oops, sorry, I'm off the screen there. My bad. There we go. Okay? So, what I would like you guys to do for homework is flip over to the back there and finish this up. Okay, this is a regression one, so you'll need your graphing calculators for this. Okay, you're going to sketch the curve and see which best fit it is. Okay, if it's quadratic, use quadratic regression. If it's linear, use linear regression. If it's exponential, use exponential regression. This is your homework, though, on the back, please. Yep, the whole back. Okay, your calculator will help you with a lot of it. Okay. All right. Again, also your homework is to charge your Chromebook tonight. Charge your Chromebook and bring it in. Okay?